Hello, everybody, and welcome back to the Power Driven Podcast. Today's going to be another super fun episode, super informational stuff we all three are big fans of. We're talking about engines, engine builds, and how to build your first engine or any engine for that matter.
So a lot of guys, their first engine build was kind of crude. I mean, mine was really crude. And then as you get more advanced, you get better tools, better techniques, you learn stuff and it gets better. We're trying to help you skip the whole
You're
crude
saying
part.
The engine builds you do now are refined from before? This is interesting to me. I didn't know that this gets worse. I'm sorry, continue.
He measures better now.
He does. He upgraded to the Fat Max.
Yeah, that's right. Yeah,
From the Stanley.
That's right.
So I'm not I build diesel engines, and diesels are sooty. So I'm not as big a proponent as super spotless clean as I should be. But at the end of the day, usually it doesn't bite me in the butt.
Because he breaks the block after 4 pulls. So that's no big deal.
Hey, I guess I could give you that. Your engine failures have never been because of contamination. Like, you can't really argue with the science.
That's very true. The ones that last long, he didn't put together.
But we kind of wanted to go over if you follow any kind of social media, diesel gas, it doesn't matter. There's always this like re-ring, 3-stone hone, dingleberry hone, slap it back together. That's how my first engine build was. I took apart an assembled, running, complete engine out of my junker drag truck.
Oh, there it is.
Brought it
And
in.
time.
And I took it apart, and I didn't have the right tools to measure anything. I just simply honed it, put fresh rings in it. I did gap the rings a little bit because at that point I'd learned that you'd wanted some gap, and didn't measure anything. Oh, I did put used pistons that I didn't measure. I got feedback. I forgot about that. So I did put different pistons in it, but used the same rods. I did them one at a time because I didn't know which way the rods were supposed to go. And so I was trying to be extra careful. I was like, all right, so the C goes this way and the notch is this way. Okay. And things like that. And so if you go slowly, methodical, without a manual or anything, you can, put pretty much anything back together.
Manual's nice because it gives you the torque specs of every bolt that you're going to use, which is pretty nice. I mean, you can also look it up just the size of the fastener, the pitch of the thread, and kind of the grade of the fastener, and kind of get pretty close. But having torque specs is definitely a big deal. You need those.
But at the end of the day,
Will doesn't need those.
but at the end of the day, I was successful using the Ugga-Dugga
Will's
method.
going to
Right?
say, like, so I found at 32 foot-pounds, they seem to get a little spongy, but like 18, they rattle loose. So it's kind of somewhere in that range. Sorry, continue.
But really what we're trying to do is share experiences, how you can be successful building engines. And
And traps for young players, like first-time mistakes that get made.
So most of our experience is in the the Cummins industrial world, and these engines are made to be like kind of a serviceable easily. So if you're just going to do like a cheap rebuild, if you get like your local machine shop has hey, here's a rebuild engine, they most likely bored and honed the cylinder wall to a standard spec. They probably didn't measure the piston to get that spec. They just measured to a standard spec because at that point the piston drops in and the rings are already kind of going to fit. So they don't gap rings. They don't machine everything. It's just a very fast, efficient way to quickly rebuild an engine that's going to go back to stock power levels, which I have never done and have no interest in doing. But I mean, that is the cheap way to do an engine. Just have your machine shop, give you standard clearances, and it works. But if you're going to make power, that kind of doesn't work so good.
And the problem with that in our industry is most people gain their experience on power with a used engine. So my junker drag truck, it had 200,000 miles on it when I started, and either 285. Yeah. 285,000 miles on it, I think. And it's either 185 or 285. It doesn't matter. It had a lot of miles. And so it's very loose.
Yeah.
Clearances have opened up. And I took it to the power level where I was blowing head gaskets and stuff was butting rings a little bit. Well, that ring gap was probably much larger than factory spec at that point.
Yeah.
And I didn't know because I didn't measure it. And so if I go back and build that to factory specs with like a 20 or 24 thousandths top ring gap, it's going to butt rings the very first time I make 500 horsepower.
Yeah, like someone could be like, oh, I took my factory engine and I made 800 horsepower. I just need factory specs and I can do it again. Not quite the same. Like, I mean, that's a great point. My dad's engine, like this was before all our awesome tools and stuff, but I went through and I measured with his pistons, what piston to wall and all that. His engine came out at 7 thousandths piston to wall. And so I just did not a 3-stone hone, but we just put a hone job through it just to clean it up. And it's sitting at 8 thousandths is just like the smallest it would clean up at. And so, yeah, I mean, that's a great engine for performance. But if you put together an engine at factory spec, I mean, the factory range is huge. But if you do it on the bottom half of spec, that's a tight motor. Not going to be thrilled making 800 horsepower or whatever it is.
I feel like for maybe some of our more novice listeners, we kind of need to like define what these acronyms are throwing out there, or what piston wall actually means, bearing clearances, what we're measuring. Like if you're doing a very, very first engine, you don't know any of this stuff.
Oh, yeah.
So
yeah, piston to wall just means, I mean, if you measured the diameter of the cylinder bore, let's just say it's four inches.
That's the hole in the engine where the piston goes.
The block,
the
but
bore.
you're measuring the block, the bore and the block.
Your piston to wall is how many thousandths smaller is your piston. So if your piston's 4 inches and you have 8 thousandths piston to wall, that means that your bore must be 4 inches and 8 thousandths. And
yeah, absolutely. And when you
that's
measure
total clearance,
not one
per
side. That's total. And pistons have special spots where you need to measure them.
Yeah,
it's not
very
just
true.
anywhere randomly. You got to know where to measure. She's about a half inch down on the
center of the
half
skirt,
inch up
half
from
inch
the bottom
up.
of the skirt.
Middle of the skirt.
And if you're ever curious, I mean, it's the biggest diameter part of the
you
piston.
can find, yes.
So like if you're not sure exactly where, just measure it in a bunch of different spots. And as long as you can repeatedly get the highest number at that one spot, that's probably it.
So pistons are
this is with-
tapered because there's more heat up at the crown, and so they're building in clearance so that when it rubs, the whole thing's rubbing, not one part. That's why you have to measure down on the skirts more.
Yep.
And what is the proper tool besides the Fat Max tape measure to actually measure your pistons? Like there's a special tool.
So the first time I did it, I just jiggled the piston and went by how it jiggled, and
you like Googled like how much distance the piston has to travel to make that decibel ring. No. If you're like home tooling, I know that you said the proper tool, but a home tool that's actually quite accurate. I actually really like doing it as a dummy check to make sure is just a set of feeler gauges. Put the piston in with a set of feeler gauges, put the 8 thousandths in, or 7 thousandths, whatever, and just kind of see where it's tight. It's a great just dummy proof way. You didn't miss a turn rotation on the dial or anything like that. The right answer and how you actually get down to the tenths to figure out what your piston to wall is you use a micrometer on the outside of the piston. You lock that at your diameter. You can record it, and then you take a dial bore gauge. And so it's basically a magnetic dial indicator, but it's designed to measure the inside diameter of a bore. Yep. You zero that on your micrometer, so that way when it's the same size as your micrometer, it's at 0, and then you stick that in your bore, and it's going to say, oh, you're 7 thousandths bigger than wherever you zeroed it at.
Yeah.
But you zeroed it on the micrometer, which is zeroed on the piston, so that tells you that you're 8 thousandths or 8 tenths or 8 thousandths, 2 tenths, whatever it is, bigger than your piston, and that's what you.
The problem with the feeler gauge, it works, but if your piston wall is like 20 thousandths, if you're trying to bend a 20 thousandths feeler gauge
you're not
to
going to
conform
do
to that bore,
you have to like stack a couple thinner ones.
It's hard to like make it work.
And that's like definitely not the right way. But like, let's just say like back in the day when
it's like your plastic gauge version of piston to wall.
Yeah, it really is. Like if I told Will, hey, I was like, I need 8 thousandths piston to wall on this block. I could go through all the work and setting up all the tools. I trust you as a builder, but I would love to just dummy proof it and make sure. Cool. I can slip a feeler gauge in there in 5 seconds and say, yep, okay, I trust him. He didn't like measure a 20 thousandths piston on me or something like that.
Yeah, just to verify. It's a good thing.
Another thing I've done that works really well, you can get those snap gauges really cheap. They're like a T-shaped gauge that's spring loaded, and they have like a little twist knob on the bottom. You put that in the bore, and then you tighten it, and that gets the size. Then you use your cheap like calipers. You caliper that. You caliper the piston. And
I mean, that'll get you within a couple.
And I'd say that gets you within 1,000th pretty easy.
Yeah.
It's not as good as a micrometer and a dial bore gauge, but
for your home
within
gamer,
1,000th for a home gamer, to me, that's what I'd used for a long time with great success.
So let's say, hey, I have my local machine shop here. I want to build my first engine. You're talking about piston wall clearance. What do I need? I mean, that's a question people have no clue about. How much piston wall does a person need? Like, is it a standard? Is it, it's very difficult to know. I know like when you order aftermarket pistons, they generally have like a range of, diameter. It's not diameters. They call it inch per inch of bore. Here's like it's 9 thousandths or 6 thousandths per inch of bore. So if you have like or that's more like ring gap. That'd be
for
ring
the
gap.
rings, they're doing that.
It's similar.
that's
big. That's a lot of clearance. Yeah, no, I mean,
we,
ring gap.
We do mostly Cummins. So just in Cummins in general, like if you get a Molly Motorsports piston, that's kind of like a cast piston, but it's upgraded, it's coated, you can get valve reliefs on it. they design those to drop in at 6 thousandths piston to wall. So if you have a standard bore engine, you've done nothing to it, you take the stock pistons out and it's not worn, put those in, they're going to drop in really close to 6. Most piston manufacturers build the clearance into the piston. So a factory 12 valve or 5.9, they're 4.015 inches the bore size. So the piston is actually smaller than that to make it have that proper, on a stock about 4 thousandths piston to wall. And on these performance ones are about 6. You buy a Molle forged piston, they have that dropping in at 8 thousandths. So they think that it only needs 8. Now in our experience, forged pistons, that's way tight.
Yeah.
But
the Molle forge is different than a diamond forge. It's a different material. A diamond forge has you drop it in quite a bit higher.
Yeah, more like 12 to 15.
Yeah, exactly. So depending on your piston type and your goals, you're going to have radically different numbers here. Also, common rail versus 12 valve are different numbers because the cooling of the pistons is dramatically different. I'm oftentimes shocked how tight we can run a common rail compared to a 12 valve.
Yeah.
So 12 valve has a jet in the saddle. It's a little plastic green or nude colored nozzle, and out of the main oil gallery or the main bearing, there's a jet of oil that sprays the underside of the piston. On a common rail, they have like a steel metal J jet. It's like a J shaped.
They have
hook.
their own oil galley dedicated to that J jet. Like it feeds nothing else.
And then up in the piston itself, they have a cast piston, and they actually have a hollow crown that J jet sprays into. So there's actually like an oil cavity on the underside of the piston, so they can pull more heat out.
Yeah,
and that's why common rail gets away with.
If like the J jets are pointing where they should, they are shooting into that galley, and so you're getting so much. I mean, I think you get more oil flow with the J jet, but you're also getting so much more heat extraction from the piston because it's being shot into that hollow crown. Like common rail pistons, they can handle way more heat, all else being equal.
I mean, just to even like drive that home, like your race truck Scrat has been to 1,800 horsepower on factory pistons. Crack the block, pistons are fine.
Crack the block, tulip the valves from heat, like just a lot of heat going through it. Like 2,200
and
degrees
no
on a
melt
dyno
on the
pole.
edge of the pistons
Pistons,
at all, right?
I put them in the new motor. I'm not gonna lie to you.
We use the pistons.
I was like, yeah, these look good. And it's a test motor anyway. I was like, all reliable.
So we kind of start with piston to wall. So essentially it depends on your power level, but for like a 12 valve, that's 6 thousandths. That's great for a 500 horse motor.
Yeah.
You get up there like 750 and higher. We like it a little bigger, more like 7, maybe even 8 thousandths. You get up over 1,000, you really need like 10 thousandths piston to wall.
Yeah.
The problem with that on a cast ring is they have a keystone ring, which means it's not rectangular. It's shaped like a keystone in an arch or that top middle wedged piece.
Hence the name.
Because
Keystone
it's
ring.
a wedge, the bigger the piston to wall clearance, the further the ring sits outside the piston, and that gap in the keystone gets bigger.
Yeah.
And so you end up with all kinds of weird dynamics going on the ring where
flutter, blow by, things like that. So
it's tough. I mean, we've ran them clear up to 12, but honestly, if you need more than 10 thousandths, you probably
you should be in the forged pistons where you have the standard. It becomes less of a street motor. I mean, 1,000.
I mean, I've taken cast pistons at 1,500. Yeah. I've taken them to 12 thousandths piston wall. I don't like them that big because it does have more blow by, so it'll work. But if I was building a dedicated street engine, I think I would stick at 10 and just try to control my temps a little better.
Yeah.
In cylinder temps a little bit better. Common
rail, you're like 6.
I mean, again, depends on what you're doing. I mean, if you have like a very mild 1,000 horse tow truck, you're running like 7, 8 thousandths piston to wall, and a lot of that is, I mean, the heat in the cylinder. I mean, like my motor here, it's like a fuel only motor. That means that it's gonna get hot. It's gonna get really. I mean, tulip exhaust valves. It running. I don't even know what the EG2 were on a dyno on a drag strip pass, but like on a couple second dyno pull, they got up to 2,200. Yeah, I mean that's a lot of heat in the piston, a lot of heat in the engine, and so with that setup, you need a little bit looser piston to wall, and that's how I set it up because I kind of knew that was going to happen. You get a more performance, like where you're going to be spraying it and you're going to be using spray to keep the burn cool. You can get away with considerably tighter than that because you don't have that heat in the piston that you would otherwise have. I guess to put numbers on it, my engine that I beat the ever loving out of, it was at 10 thousandths piston to wall. The shorty back in the day, we set up loose because we were 12 valve. That was also 10 thousandths piston to wall, and they both survived like awesome. They were great. I mean, I overheated the piss out of them. Like the shorty lost coolant in a burnout competition twice, got to like 270 degrees on the gauge. I don't know what, I mean, that was air temp at that point, not even coolant temp. But I mean, I tore it apart, and the cylinder walls, other than the half the cylinder wall being in the pan, the cylinder walls looked great. So that's kind of there. If you have like a more mild build, like let's say you're keeping it at 1,000 horse, you're not trying to you're not trying to sled pull or do like really long sustained pulls on it. You can get down to that, 7 or 8, like pretty reliably. I don't think you have many issues there.
So let's talk about rings a little bit. Ring gap. We've had an engine, your Frankenstein engine years ago. We built that at 10 thousandths piston wall, but we only had, I think we had 32 thousandths top ring gap on that. And it had triple turbos, and it made maybe like 1,300 plus horsepower, and it butted the rings. And we actually sent them into Molly, and they looked at them under a microscope and said, yep, they can see that the end had butted by the wear marks, and it had scuffed the bore all around. So if you
got crazy blow by, you're puking oil out over everything, and you've just lost compression seal.
Because essentially they butt, and then there's nowhere to go, and then it just scores the cylinder all around and makes vertical scratches. If it gets really bad, the ring will twist and it'll actually break the ring lands in the piston.
Which happened to us. We got it stuck so bad, it ripped the bottom off of the piston. Like it just ripped the
second ring groove and the land collapsed into the oil and pushed the oil ring down.
Because what happened is once it butted, we had lost ring seal on the top ring, so all that combustion pressure now is on that second ring. It had a very small, on that particular design of piston, a very small support system under that second ring. And so the combustion just broke it clear down and it's puking oil everywhere. It was great. And all because we didn't get, a simple thing, you didn't get the rings enough. And
but we were at,
we thought it was enough.
1,300. Molly said, the pistons look fine. We think you could go more with more ring gap. And remember, the very first one we put in, the Godfather, that was a cast piston. We took that to 1,800 with the same piston design. That's probably up around 12 thousandths piston wall. But I remember our top gap was like 40 thousandths on that one.
Big.
And
it's great.
It was living.
So let's talk a little bit about, loose versus tight. I mean, everybody says if it's a little bit loose, you'll know. If it's a little bit tight, everybody knows. Why, why is that a saying?
It's because if it's tight and it butts, it ruins the cylinder, has blow by, and leaks oil everywhere.
You come back
a little
on
bit
a
loose,
yes.
If it's a little bit loose, you lose a little bit of horsepower. How much is it? 5? Is it 10 horsepower?
There'll be a little bit more oil in your catch can. Otherwise,
that's great.
You'll be going rounds.
Is there any advantage? Okay, let's talk about like, I'm 40 years old. I want to build a engine with my son in my garage. It's going to be just a 650 horsepower truck. Like, what are the advantages of not going so big? If you have a horsepower goal in mind, is there any advantage to not going too big?
I do think a little better ring seal is going to keep some of the soot out of the oil. If they're a little bit tighter, you're going to have less blow by, so you have less places for it to just build up pressure and puke oil over time. And there should be a little bit of a fuel economy advantage because more of that combustion is pushing the piston down. So oil staying cleaner, immeasurable power gain that you won't really notice.
Right.
Yeah, I'm just gonna say the same thing. Like if you have, you got a lot of ring gap, a lot of piston to wall. You're gonna have more blow by. You're gonna have to, you're gonna have more superior catch cans to be able to hold it all. You got more soot in your oil, so you have to do more frequent oil changes. It's just like there's no advantage to running it too loose.
The piston rocks more at the top, so it's going to wear out the top of the bore.
It's also louder. The engine's like a little clinky.
Diesels are loud enough. Most people, especially like a 12, they wouldn't notice. But yeah, if it was a very quiet engine, you'd hear a little piston slap when it was cold if it was that loose.
So there's no real advantage to making it way too loose unless you had plans to try to do something in the future.
Yeah.
Like that's it. Like if you knew you're going to make a 600 horsepower truck and you're going to just run it for 600 forever and you're going to love it, set it up for 600.
Yeah.
Don't overbuild your clearances.
It's really true when you're building an engine, like having a realistic goal in mind, a range you're trying to think, and don't think, if you're going to go past it, build the engine differently. Like there's not a one size, one recipe fits all thing. It just doesn't. Not in engines. We have ripped pistons, rings, we have broken more crap. Like you need to really set your engine up for what you're going to do. So you need to know, like figure it out and make an honest goal. Like, oh yeah, I want a 1,500 horsepower truck. Well, if you're never going to get there, don't set up for there. But if you're like, if you have a real chance of making big power, don't build it for 500 because that's what you're at now. You really need to kind of like know what you're building it for. Just like everything, turbo sizing, transmission selection. Everything really is power specific, honestly.
So within rings, we talked a little bit about ring gap. So 12 valve, I think the max spec per Cummins is 26 thousandths. That's the end gap. So you put the ring in the cylinder an inch down the bore. You usually square it up with a tool, or if you don't, you can use the piston to square it up. Because the piston rides in the bore pretty straight, and then you use
you put an oil control ring in the piston, so that's your stop, and that way it stops the piston square. Your ring is square, and that works great if you don't have the tool.
And then you pull out the old feeler gauges, like Meyer said, and you're just checking the gap that the feeler gauge can go in, and you kind of slide it in there. And generally, 26 is a lot. I mean, that's plenty for, I'd say, up to like 700 horsepower, 600.
Yeah.
You get up there about 1,000. I like to see like 32. You're going much over 1,000. You probably should be 34 on that top ring, maybe even 36. I've built them as loose as 42 on mine, just because I accidentally screwed up when I was filing the ring. And I was like, well, they're all going to 42. And you know what? It ran fine.
What about your second ring?
So there's a big discussion. If you buy a Molly Motorsports piston, their kind of performance cast piston, they pre-set up the second ring so loose. If you have 10 thousandths piston wall, it's going to drop in at 55 or 60 on the second ring. So there's two trains of thought. Some people try to make the second one tighter because there's less heat, and so it doesn't need as much gap. Other more race mentality is gas is going to come by the top ring. It always happens. And if you trap it at the second, it can unseat the top ring and make it flutter at high RPM or high power usage. And so they want the gas path below the top ring bigger so that you can't trap gas. You get on some of these race forged pistons, they actually have a machined groove between the first and second ring. They call it like an accumulator groove, just so that there's a place for that gas to go, so it's less likely to unseat a ring regardless of what your gaps are. But Total Seal makes a gapless second ring. So it's that's going to seal up the second ring way tighter. I mean, it makes it almost have essentially zero gap because the gap is gapped with a second ring that slides on top of it. And when we test those, the oil stays cleaner. It keeps soot out of the oil. They seem to like make a little bit more power.
I've had those in my race engines for years. I mean, I know like the second ring gap is a big deal, but I've had a second ring gapless ring in my engines for years.
I personally believe the reason factories don't do that is I think a two-piece ring is less reliable for a 100,000-mile warranty standpoint. Sure. And so I think if you're trying to build a 1,000,000-mile motor, there's not enough test data for me to say that that is as reliable as a standard gapped second ring. But from the testing we've done, it seems like the benefits far outweigh any potential long-term reliability issues it may have.
Yeah, I've got them in two of my street engines now. My wife's Excursion has those rings, and then my Ruby, my tow truck, big power tow truck, has those rings in them. And so far, I mean, I'm in over a year or so, but man, I've got no complaints. Real happy with them.
But we also know, at least on a 12 valve, that second ring groove is not as strong. And so if you are catching the gas with that gapless second, you could argue that you get up there at big power and it's more likely to rip that ring groove off. But I mean, we're talking at this like mega 1,000+ horsepower level that I assume a lot of listeners aren't there. Maybe you guys are, but just things to be aware of if you start playing with, $300 ring sets. Yeah. On your $400 piston set.
But you really do need to get your piston wall clearances right and your ring gaps right. I mean, and you're going to have to do some self research. My very first big engine build, I'll say, I bought Ross forged pistons, and I was pretty excited about it. And they had these
Hellfire ductile rings.
Ductile rings. That was the big deal back in the day. They had these nasty Spiralox pins that were so hard to install. Had twin Spiralox per side. It was awful. Button caps were way, way better. But I just relied on the machine shop expertise. And I think he just looked at a card and was like, well, these pistons say this much. And I think the first time the drag strip, I started puking oil like crazy. And I pulled it apart. All the pistons were scuffed like crazy.
Weren't rings broken too? Like, I wonder if they'd butted so hard that they
may have been
broken into two. You had 2 and 3 piece rings that used to be 1 piece ring.
Yeah. I mean, I was just so excited. And there wasn't, this is long enough ago. There wasn't a ton of information out there. People knew, but it wasn't out there. Safeguarded it. You had to pay your dues. And so, which I'm hoping you guys don't have to pay those same dues. That's why we're doing this here. But yeah, I got it wrong. I put it all together and I was so excited about it. And I was, just freaking, I literally the first trip out, I just ruined this very expensive engine. And
Yeah, because it butts rings. I mean, it's not just a matter of swapping out rings.
You-
It's a matter of swapping out a lot.
yeah, the whole entire machining has to happen. And then the pistons were so scuffed, they were not reusable. I mean, they were just, it was so sad.
So before we move on from rings, obviously there's different types, but generally if you're using stock pistons, they're going to be Keystone factory style rings. But Total Seal does make some upgraded ones.
They're actually pretty new. They haven't had Keystone rings just for a little while now. So to have that's pretty cool.
These came out, and then there's gapless second or conventional second. They have both options there. You get in the forged pistons, they're almost all universally a rectangular ring. They're generally a narrower ring than a factory ring, because most performance rings are narrower to reduce friction. And so I just think there's a lot more technology in 16th inch rings. The new ones, these 2 millimeter 5/64 top rings, but 16th inch is just more common. In fact, a lot of the high end gas stuff now is going even thinner than that because, they're finding more power with a thinner ring and materials are better. But in diesels, I don't know of anybody or anything thinner than a 16th inch ring. But that's kind of, when you're talking forged pistons, you're kind of a narrow market group there. Most guys are going to be using factory pistons with, factory, a nice chromed top ring. They are directional, just so you know. It'll say top on them, or there'll be a dot, or the manufacturer's label will be on the top side if there's no other markings. They are directional. You put them upside down, it's not going to work well. It's going to chug oil and do weird stuff. But beyond rings, we didn't really talk about bore finish, like what do you got to deglaze the cylinders if you're there, but I mean, you can't just put them in the old bore and expect the rings to seat in, right? But
quickly before we leave rings, I just want to say there's a couple of reasons why you would need to have a rectangular style ring rather than a Keystone ring in a forged piston. And you kind of alluded to it earlier, we have such a larger piston wall clearance in these motors, way higher. Like we're 15 thousandths piston wall, to where that ring is now hanging out pretty far from when it's cold. And so you still have good seal because it doesn't change the geometry of the ring to the pocket it's in. It's still a tight fit. So you wouldn't want a Keystone ring if you had such ridiculous piston walls, because it's just, you'd have huge blow by issues. But anyway, that's just something thing to think about. But yeah, cylinder wall finish, that's something you've really researched a lot lately. Like we got just so people know, like we get a lot of requests to build engines, and we never have because we haven't had machines to do it. We kind of have our local machine shop, but we recently purchased awesome engines, so we can start doing some really cool stuff.
Awesome machines.
Machining, yes, machines to machine engines and blocks. Sorry, excuse me.
We're not buying engines. We're building them, dang it.
We're building them, yeah. So over the next 6 months, you'll see a lot of stuff starting coming out from us in that respect. But one of the things we got was the most modern, awesome hone there is, this Rottler super duper hone. And you've researched cylinder wall finish and know as much as probably anybody.
So the big thing on cylinder walls is the new trend. Everybody calls it a plateau hone. Well, now Rottler has coined the term extreme plateau hone.
Oh, it's like extreme deodorant, extreme shampoo.
Essentially, an old conventional hone used stones that wear away and oil bath, and they kind of scratch the bores, and the operator has to control the speed and the RPM to try to get the crosshatch all perfect. And this new one, you just dial in what speed you want it to go, RPM wise, what crosshatch angle you want, and it does the rest. It has it built in, software that monitors the load, and if it loads heavier in one spot, it knows the bore's tight. It will spend a little more dwell time there, but it's still stroking to keep the crosshatch angle. So it does these little short strokes or long strokes, or just does the upper half of the bore or whatever to get it as straight as possible. But beyond just getting the bore straight, the big thing is the profile of the cylinder. It's like any machine can get the cylinder to size with a good operator to the exact piston wall you want, but what is left for the oil to cling on? There's two things in the bore. One, it's got to be smooth enough that it doesn't wear out the rings and it's low friction. But two, it needs to hold oil, because that oil is what lubricates the rings, keeps them from galling and stuff. That's also what actually forms the seal between the ring and the bore wall. The little film of oil comes out of those little valleys, and that's what actually performs that seal between the ring and the bore. So oil is very important. Generally, as you go higher horsepower on anything, there's more fuel, and fuel dilutes the oil in the cylinder walls and washes it down. So generally, the higher horsepower, the deeper the grooves need to be to hold oil. The downside is if you have a low horsepower street engine and you have deep grooves and a lot of oil there, it's going to burn oil. Not necessarily gallons per mile, but it might burn a quart every 500 or 1,000 miles if it's too coarse. But if it's not coarse enough in the ring scuff, it's going to burn a crap ton of oil regardless if it's high performance or low. So getting that profile right is important. Where the extreme plateau comes in is back in the day, if you had really coarse stones, you're left with a really coarse finish on the wall, which wears out the rings very quickly.
Especially if they're like a coated ring or something.
And the new stuff, all the rings are coated. And so if it wears the coating off, what's the point of this nice, expensive coating if it wears off in the first 10 seconds that the engine
rough
starts?
surface.
So what the extreme plateau is they're getting those grooves, and then they're coming back with a really fine diamond CBN stone, which knocks all the peaks down and makes the bore very smooth and low friction, but it still has those valleys left
To hold the oil.
to hold the oil.
So it's like, I mean, just to dumb it down, just for people like me. So when you do the coarse grit, but you're basically making a file finish where you have the grooves and you have the peaks, and it's like very rough, coarse file. Now, obviously, it's not the same. It's not tempered like a file, so the ring will never really knock it off. But when you do that plateau hone, or the extreme plateau hone, you make it like a golf ball finish where it's got nice flats to seal on, but you got those dimples to grab the oil and hold it. So
Exactly.
cool.
Yeah. And so like, in the past, you go to your local machine shop, like, well, I've used this stone for years on the Cummins engine and it works great. And so,
I mean, even worse than that, it's like, oh, I've used this stone for years on gas engines.
Yeah.
And it works great.
I mean,
On snowmobile engines.
do you remember the first 12 valve we built and the local machine shop honed it for us?
Oh.
And we couldn't get it to seal up. It was burning oil really bad, and it was a very fine hone was the problem.
Yeah.
And finally we put it on the dyno and beat the tar out of it with a bunch of load, like heavy towing simulation. And we had to get some EGT in there. And it finally broke in. Took like 1,000 miles.
Oh,
It was burning a cord every like 300 miles or something
It
stupid.
was bad.
And it was like visually, it looked beautiful, smooth and flat and whatever, but it took forever to break in.
Mhm.
And so too fine of a hone, if it doesn't have the oil grooves to hold the oil, is a problem.
You mentioned about setting your crosshatch angle. What, like, in a typical machine shop, that's just like a person kind of like counting strokes, or could
I think they can change the gear pulley. It depends on how old their machine. Some of it is just a guy manually stroking, or if you're doing it with like a dingleberry or something, that's how fast your arm is going versus the speed. But depends on the level of sophistication, but most of them, I think the operator is controlling the crosshatch angle.
And so what angle is ideal? And is there, like anything, is there one angle that's perfect, or we have different things for different applications?
So according to like the factory service manual for a Cummins, they want between 40 and 45 degrees of angle. And that's the, that's the total between the two. So it's not like a 45 degree angle. It's
Two 22-degree angles.
Two 22-degree angles relative to perpendicular with the bore.
Yeah.
So anyway, so they have a pretty wide range. In general theory of cylinders, the longer the stroke is or the more movement, meaning there's higher piston speed, generally you want taller or flatter.
More straight up and down.
Not flatter. You want more vertical crosshatch. Steeper, because you want the oil to be able to move up and down the groove, because that oil needs to move up and down. And if it's a longer bore and higher piston speed, you need to move the oil. The downside is the steeper it is, the less ring seal it has, because it's easier for that gas to go straight down through the ring instead of at an angle.
Yeah.
And so you're playing with how flat can you make it for your performance level, and it's still steep enough to correctly move oil up and down the bore. Now, on a Cummins, because there's jets and oil spraying up there, I don't know if you really need it as steep as they're calling out, because there's a lot of oil moving around. But generally, we're just new and playing with this, but I've gone as tight as like 38 degrees just playing with it and didn't see any adverse effects. I know pro stock race guys, they're down in that below 30 degree range playing with, 25, it doesn't seal up and it burns the rings, and 30 we gained power versus 35. So it's 28 what we can get away with. So they're
really flirting with it.
Really flirting with how flat they can make it. But
anytime you're limited in your power, like you're chasing it everywhere.
And it might only be 5 horsepower, but that matters in that line.
It wins, yeah.
But for the home builder, it doesn't matter. Just make it look like a decent. I've dingleberry honed a few things, and
like
they work.
Back, I was just doing the same thing. I was like thinking back to some of the stuff like either I've seen or I've actually done with a hand like dingleberry. Like, 30 probably works fine.
Yeah.
The important thing is you can't fix or adjust what you can't measure, and without a profilometer, which is this nice Matoyo, $1,200 basically it drags like a little diamond probe through there and creates a trace of the cylinder. You can't actually know, even if you have the nice equipment, if you don't have a profilometer,
you know what you're doing.
You can't tell what you're doing. So, I mean, I've changed things just on ours with the same grit of stone. The amount of pressure I tell the machine to put on it, it affects how deep the valleys are, how broken the stones are. If the last engine I did was a 6.7, a 4.210 bore, and I went to my current race engine, which is a 395 bore, that's a different angle and it hits a different part of the stone. And I noticed it was way coarser at first till after I'd honed a couple cylinders. And I'm like, why is the valley deeper on this one than that one? And it's not just like you follow the formula. It's there. You need measuring equipment if you're going to do that. So if your machine shop says they can do extreme plateauing and they don't own a profilometer, I would tell you to either look for another machine shop or prompt them to buy the machine so they actually see what the heck they're doing.
They can prove to you what you actually are getting. Because you can see in the trace, you can see like before that plateau hone, you see how rugged it is, and you plateau.
Oh, it's extremely satisfying because not only does it give you like RA, RPK, and other things I don't know anything about, but it also gives you like a little graph, which I'm capable of reading. And so before you do it, it's just like this jagged line. It's got peaks up, peaks down, peaks up, peaks down. Might hover in the middle and then go back up.
Looks like an earthquake on a seismograph, up and down, up and down.
And that's the surface finish of your cylinder wall.
Well, then afterwards, it looks like a freaking like a heartbeat where it's just like mostly flat and then dip, mostly flat, dip, mostly flat, dip, and it's like that's like it's crazy to see like a 100 times view, 1,000 times view of what your cylinder wall looks like. It's pretty cool.
Yeah, so you get rid of all those nasty edges, peaks, and then also you're not wearing off your coating of your rings because it can slide, but you still have that oil depth.
And when you're building the engine, if you're barring it over, you can tell in extreme plateau, it bars over smoother.
Yeah.
And the first time I did, I'm like, there's no way this engine's going to break in. It's too smooth.
Oh, that's the same as
what? You know what? It didn't need to break in. It was like freaking perfect right out of the box. It's like, wow.
Yeah, that's like one of the things that I noticed too, because I just put together my motor that has the extreme plateau, and I measure like how much rolling resistance is on each, as I add pistons and rods,
how much more?
I record like the rolling resistance. I was like, dude, this thing is so easy to roll over.
Yeah.
It's like outrageously easy. It's awesome.
I remember the first time I was building my wife's excursion engine. I think it was the first one. I'm like, Will, come over and like bar this engine over, dude. It's wild. It's so easy.
He's like, something's got to be wrong. And like, I was nervous when I saw it. I was like, oh, it's fine. And I'm like, geez, it's so easy to roll over. There's got to be something wrong.
Oh, it's working great. It's working great. So on the subject of honing, a very popular thing people talk about is the torque plate hone. Is it necessary? Is it not? What is it?
So if you don't have a dial bore gauge and you're measuring with feeler gauges or snap gauges, you don't need a torque plate because you can't measure what you're there. But if you have a real dial bore gauge, you check. If I hone a block without a dial bore gauge and it's perfectly round, I'm saying within like not even moving a 10,000th up, and I mean that hone gets it within, I'd say 1, maybe 2 10,000ths if you don't hone much every time. It's so, repeatable. And we're talking 10,000ths of an inch, not 1,000th, a 10,000th.
Yeah, you look at the Cummins spec for it. It's like 2/1000ths of taper and
the whole bore, and this thing's
like
within thing's within 1.5 10,000ths.
That's super good.
If I do it perfectly round and then I put a torque plate on and do it, it moves over 1,000th. Like,
oh my gosh!
So it'll pull in one way and
so it'll come in at half a thou one way and go out half
thou the other way, and it's 1,000th out around now.
Oh wow!
Total.
So definitely worthwhile on a performance build.
And so the theory of that is when you have a cylinder head torqued down on there and all those head bolts pull, and I've noticed when I first put a torque plate on like one of our running engines, that right where each of the head studs are is like a low spot. It doesn't hit that when you very first take the glaze off the cylinder. So when those head studs pull, they almost pull the cylinder material away from the bore. And so you almost have a low spot or place where the ring has to flow out to seal. And so you don't get as good a ring seal on each of the head stud holes. So if you ever pull your engine apart and there's 6 little black dots right in line with your head studs, it's probably because it wasn't torque plate honed before. But anyways, that's the first thing I notice is it cleans up there. So the idea is when the head's on there, if it's all sealed up, you have better ring seal, and therefore the piston's running truer and the rings don't have to distort to a crooked bore, and you make more power, you're more efficient. The big question is that nobody can really answer is on a dynamically running engine with, let's say, 1,000 horsepower, those bores have to be moving all over the place.
Yeah.
And so it's like,
you got coolant pressure pushing in on them. I mean, there's a lot of forces and temperatures and everything at play.
There's a lot of stuff going on. And so does it make a difference at the mega horsepower level? I don't know. but every mega horsepower engine gets torque plate honed that I've ever done or ever seen done. Because it's like at that level, people are doing everything possible
And I
to
guess
do
you
it
could
right.
say, even though you cannot replicate a running engine, a torque plate is closer to a running engine than not. So I guess that's your best guess, right?
And I'm told Cummins torque plate hones every engine from the factory when they very first started. So if Cummins was willing to waste the time and manufacture, we're talking millions of engines here.
Yeah.
It's not cheap to bolt a torque plate down. So we do it on everything we sell.
Yeah. I remember I went to a machine shop years ago and I was building a motor, and he's like, "Oh, we don't need that. I've had good luck with these Cummins. We don't need it." And I was young. I was like, "Oh, okay, that's cool. These Cummins are so awesome. You don't need a torque plate hone." I was like, later, I'm like, he just didn't have one. If he had one, he would have liked to sell me the service of a torque plate hone. And so yeah, because they charge more for a torque plate hone because it's a service and there's more equipment and there's more time.
You gotta basically install a head. You gotta do 26 freaking head studs, and you gotta do them in sequence and lube them up, and that takes time.
So while I was young and ignorant, it's like, oh, that's cool. Cummins are so tough,
Cummins
man.
are superior.
Yeah, we don't need
those
hones.
poverty things.
But I mean, I remember years ago when I think Industrial Injection finally got their torque plate so they could do a torque plate. They made a little marketing video and they put one of those little snap gauges in the bore, and it's hanging there, and they just pushed on the block with their bare hands, and the snap gauge fell out of the block because it.
Yeah, if you can distort the bores with your bare
so many
hands.
people call BS on that. I've seen it, like a couple people do the same thing, and Industrial did it not like however long ago that was, and so many people call BS. I'm like, no, that is a thing.
Yeah,
like it doesn't take much. I mean, you're a tenth, so 0.1 thousandths of deflection is enough to just make something loose. It doesn't take much to get there.
Yeah, things move a lot more than you realize.
Mm-hmm.
They move a lot more than you realize. So yeah, I mean, getting a proper hone's a good deal. So hopefully your machine shop is able to, you can at least ask questions to them and maybe you can get satisfied with
and
them.
I'm not saying your machine shop has to have the nicest rod or machine to do the right hone. I'm just saying they can't have a 19-year-old kid that's never used it before. There's no way they can get it. I can pay my 19 or 20-year-old kid in the machine shop to hit cycle start, and that hone will do arguably a better job than the most experienced machinist in the world can do on a hand machine.
Yeah.
Because it just has so much control. Has better temperature control because it uses a water-based coolant, pulls heat out of stuff a lot better than the oil does.
So we kind of started this talking about traps for young players and obviously and the like. Obviously, the right answer to get the best surface finish and have the best ring life and everything is to get a machine shop with a good hone to do your surface finish. What would Will Terry recommend Will Terry do 15 years ago? Like, obviously, you pulled your engine out. You're just trying to do a homebrew fix. Hone, 3-stone hone. I've just talked to a lot of people who are like, oh, I'm going to open it up and put new bearings in it. I'm like, oh, if you're going to do new bearings, I would do new rings first. Rings break over time. Bearings, as long as they look good, they'll look good again. I'm like, but the problem with that is now you can't just throw that in your old bore. So what would you recommend?
So rings lose tension, and so I would say there's more performance gain with new rings than there are with new bearings, as long as they're not spun to where a journal's hot and failing. But generally, it's not that often that you have failed bearings, at least in the Cummins platform.
In an OEM application, yeah.
And so I would spend the money in the rings. My first time, I did a 3-stone hone because it was much cheaper than a dingleberry hone. A dingleberry hone is easier to deglaze the cylinder because they're flexible and they hit every bore. A 3-stone shows you how crooked it is, like where the ring stops at the top of the bore and changes directions, it wears more. You do a 3-stone hone and there'll be a dark line there where it doesn't hit, where a dingleberry hone will hit the first time and be like, oh, this is perfect. I've deglazed it. It looks great. So to me, the 3-stone hone with WD-40 and trying to clean it for just a cheap job was great, but that's all I could afford at that time. I mean, I barely afford the head gasket that I had to put on there. So, but if I was to do it right, like let's say I wanted to actually race competitively and stuff, or I wanted my tow truck to be reliable, I would spend the money because my block also needed to be surfaced. But it was like a 6-month lead time in the machine shop, and they wanted like $300 to surface the block. And I was like, and I measured the head, and it was rainbowed, and the block matched it. And I was like, well, a rainbow on a rainbow is going to seal up, and that's what I did, So
yeah, I mean, the right answer is, but so I guess if you were stuck in a field with an engine that needed a dingleberry that you had to put new rings in, you would like 3-stone and finish off with like a fine dingleberry. Is it?
So the Will Terry method is get the coarsest 3-stone I can, and then get the finest 3-stone and do the other direction so it breaks. Because when you hone, it like tears the material and leaves little burrs. If you go the other way, it's just like cuts; it'll break off.
Okay.
And that's the most homebrew way to get a homebrew version of Extreme Plateau. That's not perfect.
It's still terrible, but
I mean, I went and checked some of the stuff I had, and I had these really coarse stones. I was like, oh man. So in like a race engine, we went the RVK, that's the valley depth in microns, over 100 thousandths microns deep. I mean, 100 microns deep. My most aggressive, like 80 grit stones I could find, yeah, it's like 60 on the valleys.
Yeah.
and the surface finish was super rough. It was like 50 on the peaks, where
Yeah.
our peaks are under 10. I mean, so it just wore my rings out really fast and wore all the coatings off them. But it did hold oil after it wore all the coating off the rings and wore them out in the first 5 minutes. But at the end of the day, like, so your most aggressive homebrew stuff I found, you can't come close to what the diamond. You have to be diamond stones too. We can't do it with a regular stone. It has to be diamond. But
Another thing, like back to like measuring clearances, we got piston wall and ring gap. Another big thing is your bearing clearances. You're talking about your bearings don't fail, but if you're putting together a fresh motor, you kind of need to make sure your bearing clearances are correct.
Mm-hmm.
And so it's kind of a similar type thing as your bore gauge, but
so you can use snap gauges like I talked about, the snaps, and when you lock it down, it holds, and use your calipers.
Oh, dude, I can't believe you started with that.
To do that?
That's terrible.
But I think the easiest home game by far is plastic gauge.
Plastic gauge, unfortunately, it works. It's very foolproof. It's nice for that purpose.
And that's these little wax strips. They have green and red color. I think Power Sealed makes them, and
Plastic you go to Napa and get them.
Any
Molly
auto
makes
parts store
some.
probably has it. Yeah.
Yep. But yeah, so you just put a little strip in there, and then you clamp it down, and then depending on how wide it's squished out, it tells you how much clearance you have. I was talking to someone like a couple of weeks ago, and he was trying to tell me he has a little bit more than, or what was he? Somehow he said like a little bit less than 3 thousandths, and I was like, oh, like on the mains, and I was like, oh, like that's a little tight. And he was like concerned about it, whatever. And I finally realized he was talking about it was a little thinner than 3. I'm like, okay, that's at least more in the ballpark. So like when you
now the Cummins spec, I think is 2.5 to 5, or is it 2 to 5? I think it's 2 to 5, and it's 1.5 to 4.5 for the rods.
Which this guy was like building them, like trying to make it like 1,000. So I was like, you want more.
But the Will Terry homebrew method, I didn't have a way to measure. I checked one with plastic gauge and it was fine. And I was like, this was a running engine before.
That's my favorite thing to do, is to pull apart a running engine and then make some small tweaks or whatever you're going to do and put it back together, because it's like everything worked. Yeah. Chances are this will also work.
And as long as the bearing you got wasn't bad. So to me, at that point, the plastic gauge is to make sure the new bearing, if you're putting new ones in and not reusing bearings, which I recommend. I've reused bearings, but if they don't have good spring tension in the rod or the main cap, they've been stressed. Like, I don't like it. If they don't fit in tight, to me, that's not a candidate to reuse.
If like they almost like they should like pop in and like lock in, like you can shake that rod or whatever as much as you want. It won't fall out. If it's falling out, like that's the first failure point for the bearing. Either long time over wear, or if it started to get hot a little bit at one point, or getting bashed
kind
in.
of takes a smaller set than it was, and it doesn't have the spring and
it'll clamp in, and it'll barely sit in that rod or main journal, whatever, and it's like first failure point that you can catch before it actually failed.
Let's talk about, bearings and contamination, like what needs to be clean when you put bearings in so you don't have contamination.
So this was a fun one for me, because like the first time I built an engine, Todd, you were helping whatever, and I was like super worried about between the crank and the bearing, and I was like, I gotta make sure this is clean, and you're like, you're being dumb. I mean, it's like the main thing you need to worry about is between the journal and the bearing, because whatever debris is in there, it's gonna be there forever, and then you're gonna create a high point in the bearing, and that will like tighten your clearance in that one spot. That'll get hot and inevitably lead to the failure of the whole bearing. So when you're doing it, make sure between the journal and the bearing is clean. And what I like to do,
the main cap or the rod end.
just wherever between your metal and your bearing. That's what's important. I mean, obviously cleanliness is good everywhere.
Yes, everywhere.
But like I'm most worried about between the journal and the bearing. So what I like to do is I like to get everything clean, wipe it down really good, and then I'll spray with like my brake clean or whatever the journal and then the back of the bearing and slap it in. So if some
While it's still wet,
while
right?
it's still wet, and you can use like, what was it?
ATF is what some people use.
Yeah, what was that company that was using ATF? But anyway, it doesn't really matter what it is. I like doing it with brake clean because it's just like it keeps the rest of the engine clean while I'm still working on it. But what that does is like, let's just say there is somehow a little piece of dirt or something that landed
lint
in there
from your lint-free blue paper towel.
or like whatever it is,
Yes.
that helps that flow out while the bearing's getting pushed in.
Gives an
So
escape path.
it's like everything should be clean, but in case it somehow isn't, that's like another just precaution to take to make sure everything is actually extremely clean on the way together.
Yeah, and you can see in your bearings, like if you pull them over apart, and you'll see there's little like looks like a BB or some little high spot in your bearings, like a little round thing about the size of a BB. There's probably a speck of dirt underneath it, and when you get the pressure these things see, that is a high spot in the bearing, and it starts to wear away, and it'll shorten life of your bearing.
I've had like some kind of like snake looking things, and it was just metal shaving behind my bearing.
Jeez.
But I don't know why. It's
Oh,
clean, but
gosh.
Yeah, that's a bad idea. So yeah, like between the bearing and where the bearing sits into is really your main concern, because as soon as oil's in there, I mean, you're gonna put assembly lube or grease, which that's a whole other thing. You need like assembly lube that'll kind of float the contaminants, and the oil pressure will just wash it away between the crank and the bearing. You know, so that's really the big concern is between the bearing and the thing the bearing is sitting in.
Most of the contamination I see in a main bearing or like any bearings isn't from the bearing itself on assembly. They're generally lined up right there with the oiling hole, which tells you it was probably in the oil galley before the engine was started. And so like that's also another thing is like, your machine shop gave you your block and they say, oh yeah, it's clean, it's ready to go. I probably wouldn't trust it.
Yeah, you need to clean your block, get some brushes, get some stuff. I mean, you need to make sure that block is clean.
So if you're a home gamer and you have this apart, I mean, whether you're using new bearings or not, you should just check. Plastic gauge is a quick, easy check. But a lot of times when guys are there, like, hey, I'm going to put rod bolts in there. But my machine shop says I need to resize my rods. I want to put main studs, but machine shop says I need to do a line hone and a main line bore and everything because I put these stronger fasteners in there. So true or false? What do you guys think?
I mean, it does tighten your clearance slightly, but it doesn't tighten the clearance enough to, like, an HX bearing gives you an extra thousands of clearance. It tightens your clearance up less than that. And so you can put your clearance back up with like either splitting an H and an HX to get half thousands of clearance, or you can run double HX, or the X stands for extra clearance on a Molly bearing, to get a full thousands bigger. I don't believe like that you have to reline bore anything, because when I've measured it, also when you measure a bearing, like you get in there with your dial bore gauge, the tightest point is directly like perpendicular with the cap line. And so right there is tightest. If you measure it like a 45 on either direction, you're a thou or 2 thou up from that. Like, it's not like you're going to create tight points, whatever, if you put studs in there. No, your tightest point's still going to be the top, and the sides will get looser, and then you can run your HX bearings or something to get your clearance back. That's my opinion.
Yeah, I mean, I would agree with that. You can get your clearance back. I do like between Will and I, we're the different. I'm more of the stickler. I want it perfect. Like, I would like to have like a perfectly round hole for my crank, even though I know the bearings make it not round on purpose, so that's probably a concept you don't really
Wait, you mean
realize.
the bearing has some taper built into
It
it?
has to, otherwise you're gonna have a real problem.
I'm also gonna say that an old block that's been beat to hell, and especially if it's overheated at one point, or
It's not
if
round anymore.
your bearings were trashed when they came out because they got galled and spun, those bores are not lined. Those bores are not round. So if you got it, if you had one of those issues and you don't have it line bored, yeah, you could definitely have an issue.
Yeah.
If it's somehow got line board and you change direction with your build and you decide to put studs in there, I wouldn't be worried about it.
Yeah, if you pull your engine apart and your mains are blue from heat, you might want to get that line board.
Yeah, no kidding.
We got a problem.
So in my experience, going to a stronger fastener does tighten it up, but let's say it's
2/10.
2, maybe 3/10. It's not enough that if you are running extra clearance bearings, you can't accommodate with that. But that said, gosh, if you're building a kind of unlimited horsepower type thing, you're spending a lot of money in good parts.
You should expect.
It's very easy, because who knows? I mean, if you don't know the source of your block, what if somebody played musical caps? I mean,
That's true.
There's all kinds of things. So we do have line boring capacity here on our new machinery, and it's pretty fun to go in there and just kiss the journals on a block, but it takes a long time to put it in there, the fixture and everything. even with modern equipment, it's not a 50-cent job to do
No,
that. You
it's
know, it's a
still
little
pretty
bit of
spendy.
it's definitely a little bit of a job there, but
What about bearings themselves? Like, this is something probably people don't know, is you don't have to use the same size bearing on each side of the rod or the main. Like when you're setting your clearances, they have different thicknesses of bearings. You just need to set the thickness on that exact hole. And so you may have like an extra clearance on one and a standard clearance on another to get the clearance you want, because you, in your mind, you're thinking, well, they're different thicknesses. How can that possibly be? And why does that work, Will?
it's magic.
It's magic.
I mean, it works because the bearings aren't perfectly round, and
Where the bearings meet, your crank never touches. That's the widest point of your bearing. It's there, like, so even if there's like, if you had to pretend there's a little edge there.
See, I didn't know that. So you just educated me on
It's
something.
like he said, the narrowest part is the top and bottom of the cap. That's the thickest part of the bearing. And the thinnest part of the bearing is on the edges, so the oil can get in and make that hydrodynamic wedge. That's the path the oil takes to get between the bearing and the surface.
I mean, sounds legit, right?
I read it in a book somewhere. It's probably true. It's been a while.
No, it is true.
Yeah.
No, that's very true. When you said that, the memories came
Yes.
flooding back. I'm just getting a little old, but
But that's why you have different thicknesses bearings, because where they are different thicknesses, the crank's not even there.
And I think that, like, in an absolute perfect world with everything rigid, it wouldn't be ideal, but it'd probably work. However, in the real world, where that your crank is whipping around like a wet noodle,
It's gonna
as long as the oil has the clearance enough to where it can move around and put some oil in there so it doesn't gall and it's not too loose so all your oil pressure goes away, it's probably just fine.
yeah.
speaking of bearings, I mean, we can talk about the different types of bearings real quick too, but as far as oil clearance in there, we found the Cummins specs are fine. You can go a little on the high side if you're going to run thicker oil and you don't really have any adverse effects other than low hot idle oil pressure if you're not running a thicker oil.
Right.
But I mean, I've ran some stuff pretty tight, and it seems like you can get away with a lot on that.
As your
on
RPM
your
goes
street
higher,
engine.
as the RPM goes higher, you probably want to loosen up a little bit because they are whipping around more, like Myers says. You need a little bit more, but yeah, as long if you're within Cummins specs, just go on the high end for big power, high RPM, mid range for everything else, probably fine. Another thing I want to talk about quickly, about out of time here, is assembly lube. Like, it's kind of a big deal. I
You
mean,
want to skip over the types of bearings between P, H?
fine, go
People
ahead.
don't know.
Hurry, go.
So your standard bearings are a P bearing in Molly's line. They become more of a lead-based type bearing. That's like what Cummins would have put into the factory. The very soft bearing, handle contaminants. H bearings are harder, and generally high-performance guys all like the H bearings. They take more abuse. The surface doesn't spall off as much. Sometimes you get a P bearing really hot with higher PM or whatnot. It can almost like flake off the surface and delaminate. And then the V bearings are kind of what they run. They're back like a high performance, but they're soft, and they are even less likely to shed off than an H bearing, but they are softer. And so like a Top Fuel guys, they use those because they can tell if their tune-up was aggressive, the bearing will actually mushroom out under the rods and flatten. It's almost like a tuning thing, like, hey, we're right on the edge of like blowing this thing up because we're squishing the bearings out X amount after that run.
Wow.
But
Pretty wild.
But yeah, that's your main. And then the X on the end means they're extra clearance. They used to have a K marking if they were coated.
Now,
Coating is common on modern engines for like all this start-stop cycle bull crap that they do. So they're good for dry starts is what you can learn from the OEMs there. But it seems like on the big power stuff, it wears through the coating and you're into the base bearing anyway. So I don't know but anyway.
And then isn't Molly's coming out with another, I forget, I was talking to their rep there, and they have another bearing that's coming out that's kind of like very similar to the V's, but like the newest, latest, and greatest. It's kind of
cool.
almost going to replace the V's. I forget what like letter they had for that, but it was like X or K or something like that, but it's probably wrong. But he was pretty excited about that. But something else I want to talk about on the bearings, just touching on that front, I've seen a lot of people afraid of H bearings in street trucks because they think that H bearings have like a limited lifetime. And so they're good for high performance, but don't put them in your 100,000 mile motor. Talking to the Molly rep, he's like, that's bogus. He's like, if after 200,000 miles, your P bearings were going to fail at the end of the road trip, the H's may fail like halfway through the road trip, but that's like the only difference. It's very, 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 very minute. And then just from us and our experiences, same thing. Like I've never tore into a motor that's been together for a while and been like, oh yeah, wow, those H's were about to go.
We have had trouble with P bearings though on one of your engines going over 1,000 where it was delaminating.
Yeah.
It hadn't failed when we pulled it apart. We're like, wow,
Yeah.
this bearing material had like almost like friction welded, sloughed and moved, and then reattached to the bearing. It's almost like a whole flake had come and migrated in several of the bearings. And I don't know if that's the high oil pressure when you get extreme force on that hydrodynamic wedge, if the oil actually like spalls up the surface and moves it, or if it I don't know what happens there, but all I know is pieces of it almost looks like flakes moved over on it, and it was like not looking, it was kind of cracked looking on the surface.
So I guess
we've never seen that with the H's.
So basically, for our recommendation, up to 1,000 of P bearing is pretty darn good. H's are not a bad idea. If you got the extra money, you want to build an 800 horse engine, H's, and you want the reliability and don't want to deal with it or worry about it, have the room to grow. H's aren't a bad idea. They're great for the street, towing, all that, no problem. And H's will basically do anything you need them to do for most.
And there are a lot of high horsepower builds.
99% of performance engine builders, they're doing.
Now,
just
if you
fine.
build your engines dirty like I do, the V bearings are better because they handle contamination a little better.
You can, you can put some dirt in there.
They're more like a super strong P bearing that can handle trash, but also handle the horsepower.
Okay.
Yeah. Well, guys, honestly, we're out of time. I got to roll, and we've been here for about an hour already. It's crazy. I know. I don't know, guys. Did you guys like this discussion out there? Give us in the comments. Like, there's lots more we could talk about. We've kind of got through a lot of like the most important things, the clearances, making sure it's setting right.
This was basically bottom ends. We didn't even get any top
Heads,
ends, so maybe next time.
Or head studs or torques or when you need them, all that stuff. So anyway, I hope this is interesting, you guys. If it was, let us know. We may go to part 2 on this one. And so thanks for coming. Thanks for hanging out. And we'll see you next time on the Power Gym Podcast.